This is part 2 of chapter 6. So we are going to look at what are the configurations for the enterprise network architecture. Okay, so in part 1, I've already explained lah sebenarnya untuk enterprise network architecture ni for a hierarchical LAN design. So kita sebenarnya boleh buat dua configuration lah. So satu, kita boleh buat the full 3 layer design. Maksudnya kita ada core layer, distribution layer dengan access layer. Alright, so next sebenarnya kita boleh buat a 2-tier design ataupun kita panggil collapse core. Okay, so like I mentioned, selalunya keadaan network tu ataupun size network tu mungkin pada masa company or organisation mula dibuka, mungkin dia punya size, employees, bilangan device tak begitu besar dan bajet juga mungkinlah kurang daripada company yang medium to big size companies. Okay, so usually kalau company macam ni basically mungkin dia punya network hanya dalam satu building sahaja. Jadi in this case it is not necessary that we have a distribution layer and also a core layer that is separate. That means kamu tak semestinya perlu ada different physical switches to do the jobs of the core layer and the distribution layer. Okay, so kita boleh combine the jobs of the distribution layer and the core layer within one or two layer 3 switches. Okay, so yang ni yang kita panggil collapsed core. Maksudnya kita collapsekan the core function dan letakkan dia dalam distribution layer. So in this case, bila buat collapsed core, that means it is a cost effective solution lah. Maksudnya kita tak perlukan separate physical switch untuk buat dua tugas ni. Okay, alright. So basically bila nak consider either you do a collapse core 2-tier or 3-tier, so kita tengoklah kita punya planning in the organisation. For example, that whether you nak expand in the near future and whether let's say you have your own in-house IT department or you want to outsource. Kan, so selalunya kita kena in-house lah, right? Sebab kita manage mungkin a small network sahaja. Okay, so bila kita combine kan tugas core dengan distribution layer, so kita kena tengok lah sebenarnya these two sections lah, two different task. Okay, satu is connectivity to the one edge. One edge maksudnya nak connect kepada internet, whether we have a data center, ada service provider dan apa-apa service lagi yang melibatkan the internet. The internet maksudnya kita punya service provider dan network luar. Right, so tu satu tugas, satu section of the duty which is usually done by the core layer. Next is when we want to aggregate our access layer switches. For example, your LAN. Okay, so kita nak worry about the layer 2 functionalities. Right. Okay, so ada function masing-masing lah. For example, the data center is where business critical servers are placed. So we have to do some configuration so that the task can be done for the connectivity to your essential business critical servers. And then when you want to connect to the outside world, to the internet, if your company ada e-commerce, okay, then if you want to have a remote branch, how is the connection going to be? And if you want to have a remote worker, nak bagi staff kerja from home, right? So you want to provide a remote VPN. Semua tu tugas di one edge. So you must have a collapse core switch yang capable of doing that. Okay, so yang biasa ataupun yang konvensional adalah 3-tier lah. So kita separate kan tugas core layer dengan distribution layer, right? So bila company yang besar, it is productive and cost effective untuk implement a 3-tier design sebab size company yang besar dan mungkin dia punya campus network tak span hanya satu building. So we need to have multiple distribution layers to connect between the two buildings. Okay, so dekat satu building kita ada more than one distribution layer. Okay, 2 and upwards lah. Alright, so kita nak aggregatekan multiple end users. Kita nak aggregatekan the access layer switches. Okay, dan mungkin kalau company tu lagi besar, bukan sahaja multiple buildings, dia ada multiple sites. Alright, jadi the core layer is needed to aggregate all these different and remote distribution layer switches. Okay, so itu mengikut skala lah, mengikut scale factor. Okay, so kita tengok pattern untuk 3-tier design. So katalah contoh kita ada campus network design. So campus network design ni dia akan follow pattern yang sama je for the 3-tier. Maksudnya ada access layer, distribution layer mesti ada pair, okay, and then the core layer. So the core layer we have a pair to connect these two pairs. Dan kita boleh reuse lah pattern ni. Jadi dekat setiap katalah dekat setiap branch. Okay, so ni kita panggil 3-tier design or a hierarchical design lah. Okay, so dia macam north south, maksudnya daripada atas ke bawah and vice versa. Okay, ada satu lagi, instead of the 3-tier campus network ni, ada design yang lain yang kita panggil spine leaf 3 leaf spine design. So leaf spine ni for example dalam sini dia letak dekat data center. Sebab apa? Dia ada multiple server and dia macam kita panggil east west, maksudnya it's between the communication of these servers, dari kiri ke kanan, kanan ke kiri. So dia nak highlight the communication between the different servers. Okay, next kita tengok pula when we want to consider the access layer switches ni, whether we want to configure the VLAN in a certain manner lah. Okay, sebab bila dekat layer 2 kita kena ambil kira spanning tree protocol. Okay, jadi spanning tree protocol function dia adalah kita akan block a certain ports. Okay, sebab kita tak nak looping. Okay, jadi bila kita buat macam ni, if we have multiple VLANs, kita kena design whether that particular VLAN kita nak access dia adakah dekat setiap access layer switch ada VLAN yang sama, ataupun kita restrict VLAN tersebut hanya dekat satu access layer switches sahaja. Okay, kalau Cisco, it is recommended to restrict a VLAN to a single access layer switch. Right? Sebab apa? There is a risk of topology loops. Okay, so kita tengok apa masalah dia topology loop ni. Katalah kita implement VLAN 10 hanya dekat access layer switch satu sahaja, and then another VLAN on a different access layer switch. Okay, so if we have a spanning tree protocol implemented, this will not cause a problem lah. Right? So kalau kita implement VLAN yang sama spanning multiple different access layer switch, nampak kita akan ada blocking. Right? So bila VLAN 10 ni span between the two access layer switches, the distribution layer switch mungkin treat them as separate access layer switch, jadi dia mungkin block. Unlike VLAN 10 here, dia hanya ada kat sini. So if one of the ports are blocked, dia masih ada alternative route to another distribution layer switch. Okay, so itu antara consideration lah. So if you want to manage properly, if you know where to prevent the looping, then it's fine. If you want to have a VLAN that spans across multiple access layer switch. Okay, so anyway, dalam spanning tree protocol pun ada beberapa cara how we want to manage our STP topology. Okay, tapi ni salah satu consideration when we want to design. So apa yang kita nak tengok whether it is STP based or not. So if it's taking into consideration the loop and the blocking, then kena ambil decision lah untuk buat design yang mana in terms of layer 2, for example your VLAN design. Okay, next kita dah tengok baru-baru ni our first hop redundancy protocols. Alright, so selalunya lah macam yang kamu buat, configuration dia adalah if you have multiple VLANs, so you separate ataupun you bahagikan. For example lah, if you have 4 VLANs, right, so 2 VLANs will have one gateway, main gateway, primary ataupun active, and then the other 2 VLAN will have the different switch as their gateway. Alright, so protocol yang ada, of course you've gone through this, your HSRP, VRRP, and also we've learned a little bit about GLBP, although I didn't give the assignment for the lab. So you know the difference between HSRP and VRRP and GLBP adalah yang ni dia ada lebih banyak backup. Yang lain ni ada satu active or primary and the other is backup. Okay, for GLBP dia support more than one backup. Alright, jadi kita boleh buat load balancing mengikut keadaan trafik yang kita nak lah. Okay, so as the technology evolves, selalunya lah selepas cost untuk layer 3 switch turun, ada company yang mampu untuk buat access layer dari segi hierarchical network design ni. Access layer dia sebagai switch layer 3. Okay, so ada another alternative. Tadi kita nampak bahawa if we implement the connection between the distribution layer and the access layer at a layer 2 punya connection, then we need to consider about spanning tree protocol. Jadi katalah kita mampu and we do not want to have the complexity of the spanning tree protocol, we can implement the access layer as a layer 3 switch. Maksudnya dia boleh handle IP addressing. Okay, so in this case the communication tak ada lagi, kita eliminate the problem of this blocking ports. However, now we have to configure all these at a layer 3. Okay, so kat sini dari segi IP addressing pula lah dia punya management. Okay, alright, so basically this is in terms of how you want to manage lah, whether you want to consider using IPv4 or layer 3 IP addressing for your access layer switch to distribution layer switch connectivity. Maksudnya dari segi IP lah pula kena consider. So some of the advantages kalau kita implement routed access dekat access layer switch, kita jadi routed port. Okay, so in this case there is no need for first hop redundancy protocol. Okay, so sebab dia nak cari gateway kan kalau dekat layer 2 to layer 3 ni. Jadi kat sini kita hanya perlu fikir pasal routing je lah. If they are between two IP yang sama, jadi tak ada masalah lah. Okay, ada as long as ada connectivity. As long as the link is not down, then you can select whichever routed port yang boleh dilalui untuk jadi gateway untuk connectivity. Tak ada lagi kalau dekat layer 2 kita perlu satu IP as the default gateway. Okay, alright, then of course we eliminate the STP. Okay, and then we increase the uplink utilization. Of course bila kita ada routed port ni, selalunya dia punya bandwidth capacity adalah lebih tinggi. Okay, so you can increase the effective bandwidth available to the end users, right? And then it's easier to troubleshoot because it's simply layer 3 punya IP addressing issue lah. Like I said, for example, if we want to test connectivity, kita boleh gunakan ping dengan trace route. Tak ada lagi nak troubleshoot masalah STP. Nak kena detect siapa root bridge, nak kena detect port mana yang block, nak kena detect port mana yang forwarding. Okay, and then if you use layer 3 IP addressing, you can manage using your dynamic routing protocols lah. So this ensures faster convergence sebab dynamic routing protocol dia ada algorithm dia sendiri untuk converge, okay, without having manual configuration. Okay, so kita tengok pula alternatif bila nak design ni juga ada beberapa feature lah. For example, yang Cisco design, macam mana cara kita nak enhance kita punya design ni. Right, so for example, kalau dalam Cisco kita ada virtual switching system ataupun switch clustering lah, kita kumpulkan beberapa switch and then jadikan dia sebagai seolah-olah satu physical switch. Okay, boleh juga gunakan konsep stack wise. Okay, so stack wise juga Cisco punya teknologi where you stack multiple physical switch dan dia jadi satu logical or virtual switch lah. Kita manage dia seolah-olah dia satu switch when in actuality it is different physical switches. Okay, alright. So dengan cara kita manage macam ni, it ensures simplified design. Okay, so maksudnya cara kita nak manage tu on top, instead of kita manage banyak-banyak, kita manage satu untuk banyak. Okay, then advantage yang sama jugalah macam if we do a routed access. Okay, kita gunakan layer 3 untuk access layer switch. Okay, maksudnya tak ada STP management dan tak perlu manage first hop redundancy protocol. Some other advantages ni lah. Okay, basically konsep dia sama lah. Maksudnya kita nak simplify kan kita punya campus network design ni so that we can manage easily and it's easier for us to troubleshoot. For example, this is one configuration. Okay, so the connection between the access layer to the distribution layer can either be layer 2 or layer 3, and then at the layer 3 or distribution layer switch kita manage menggunakan VSS. That means kita anggap dia sebagai one logical switch. Okay, instead of kita manage dia sebagai dua physical switch, we manage that as if it is one single switch. So this is the logical layout. Okay, nampak macam satu lah, right? So this is the view, overall view when we have connectivity with other one edge services. Semua basically kita reduce dia menjadi nampak macam seolah-olah satu lah. Okay, so this is called an optimized architecture, and advantage dia adalah easy to manage, resilient, more flexible, and also higher aggregated uplink bandwidth capacity. Okay, so ada lagi satu teknologi yang current lah mendapat tempat dekat kita punya industri. Okay, so Cisco pun sekarang tengah promote yang ini. Right, so bila kita dah nampak konsep ni, that means we can manage them as easily as if we have only one device. Okay, so idea ni dah dikembangkan dalam konsep software defined networking. Sebenarnya konsep software defined networking ni previously lah, dari segi research dah lama. Cuma implementation dekat industri ni lately dah masuk dalam industri dengan meluas. Okay, right. So this is the industry's first intent-based networking solution for the enterprise. So apa maksudnya intent-based ni? Maksudnya kita boleh targetkan tujuan kita, macam mana cara kita nak gunakan network kita. Okay, so bayangkan kalau kita ada multiple connection kepada internet. For example lah, dekat network kita, dekat company, kita ada dua cara. For example, we subscribe to Unify Business satu. Lepas tu kita kata, okay, kalau Unify Business down, can we have another service provider or another technology by the same service provider? Okay lah, pakai DSL. For example lah, DSL ni slow kan, tapi kita nak ada internet backup, so kita pakai. Jadi kita in essence, kalau dari segi traditional, we have two different equipment. Alright, okay, but let's say tadi kita kata okay, kita jadikan management of these devices seolah-olah satu. Right, so now katalah ada satu network equipment yang kita boleh gabungkan semua. Katalah dalam contoh saya bagi tadi dua, ataupun in the future we have multiple devices connecting to different technologies. Okay, katalah nanti ada satellite yang murah, kita kata okay, lagi satu backup, kita connect ke internet menggunakan satellite. Okay, tetapi kita manage ketiga-tiga connection ini menggunakan satu controller. Okay, so that is what is software defined access. So bila satu controller, we use programming language untuk kita manage the different technologies. Itu yang dipanggil software defined. So that's why sekarang kalau kata student dulu nak masuk network sebab tak suka programming, but now everything is about programming. So we manage all these seolah-olah dia satu dengan satu controller. Okay, so kita tengok produk Cisco lah. So Cisco dia panggil ni sebagai Cisco Digital Network Architecture or Cisco DNA. Alright, so it's a combination of the campus fabric design. Fabric design ini adalah membawa maksud kita punya switch ni macam mana connectivity. Ada berapa link, ada berapa port, daripada port mana nak connect kepada port mana. Maksudnya kita ada underlying equipment. Underlying equipment dia manage connection. Satu router kepada kita punya list line, ataupun satu router DSL, satu lagi router Unify for example. So it's a fabric design. Okay, and then macam mana nak manage? We have the DNA center. Okay, Cisco DNA or DNA center. Ini seolah-olah macam dia punya controller. Dan kita boleh gunakan software lah. Kita tambah capacity macam mana nak manage. Jadi satu controller tu boleh berfungsi jadi router, boleh jadi firewall, boleh jadi modem dan sebagainya. Alright, so it adds fabric capabilities to the enterprise network through automation. Fabric capability membawa maksud what kind of different connection. Physical connection pakai kabel fiber ke, pakai UTP ke, pakai macam-macam lah, wireless ke, right? But you provide through automation. So if you've learned also ITT652, you gone through one chapter about automation, which is simply you codekan. Kita codekan all the possibilities kan. So it's basically software based lah, or software defined, right? So inilah dia punya capability ataupun advantages. Okay, so automated end-to-end segmentation to separate user, device and application traffic without requiring a network redesign. Jadi dari segi physical tak perlu lagi kita nak tukar kita punya design or configuration. We just manage through software or coding. Alright, okay, so that's the trend that we are going to lah, we are moving forward to. Right, so that's it for enterprise network architecture.